G'day, welcome to 24 Hours a Pass, growing our community. Today we're pretty excited to welcome Jeff Renz session about the introduction to Azure DocumentDB. As you probably know, 24 Hours a Pass, 24 straight sessions, great SQL content, and I think Jeff's session is number 9. So to access any of the on-demand sessions in future, just head along to the 24 Hours of Pass site, www.24hoursofpass.com, and you should find all the session links. My name's Martin Catherall. I'm a SQL MVP, do a bit of work on the program committee, and I'm a regional mentor in the Australasia region. If you're going to be at Pass, I'll see you there. I've just got a few slides to get through, a bit of housekeeping, and the first one involves technical assistance. If you do have any need any technical assistance during the webinar, just type it in the panel on the side. Use the Zoom button located on the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The question pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Since all the attendees are muted, you'll need to submit questions by typing in the Q&A field. Now, we might leave most questions to the end, but I think Jeff will pause at various intervals and ask if we've got questions. Now, this event wouldn't be possible without our very excellent sponsors, and we've got a few big sponsors here. We've got Microsoft, Cisco, Dell Software, and in addition, we'd like to thank our support sponsors, which are SQL Sentry, HP, and SolarWinds. They're the guys who make this event possible, and go look at their products, please. Now, let's just make a brief mention to the 24 hours of, to the Pass Summit, which is coming up later this year, the end of October, early November. There are 5,000 people from around the world, 52 countries represented, taking place in Seattle, Washington from October the 22nd. Pass Summit delivers on providing you with the answers to your SQL Server issues, along with knowledge, strategies, and skills you need to stay ahead of the curve. So, and you can get a $150 discount with your chapter code. Right, so let's find out about our speaker and introduce Jeff Renz. Jeff's a SQL, well, he's a BI architect. He tells me when he's not learning new stuff like Azure, he's practicing to speak about it. He loves playing golf, and I recently found out that Jeff he's a very tall bloke. I've never actually noticed, but he is. But he drives a very small car, which apparently gets a lot of laughs because he looks quite comical in his Toyota Prius, squashing in there. So that's enough from me. I'll move on. Hand over to Jeff. Remember, get your questions in if you've got any, and yeah, take it away, Jeff, please.
All right, thank you, Martin. So thank everybody for attending my session. This is an introduction to Azure DocumentDB. So what we're going to attempt to cover today is just sort of getting going with Azure DocumentDB, creating and working with JSON documents, Azure DocumentDB overview of features, the user interface, backend to call and consume and put data into DocumentDB, and then in the end, JSON validation. So I feel like it's a very important thing that everybody gets a good understanding of JSON. So when we are talking Microsoft Azure DocumentDB, we're trying to figure out, well, what is it? Where does it sort of fit into the stack of offerings that Microsoft has? So you can sort of see when you're working with data, structured data like SQL Server, you could have it inside a VM. You could have Azure SQL, or you could connect to it as a service. You could store data in DocumentDB, which would be JSON document structures. You could put data in tables and blobs. So part of what we'll see is that we get the schema-free queries. So there isn't structure. You don't have to fit data into a predefined format, which I think is one of the advantages of DocumentDB and just sort of playing around with it. It's been a different experience where designing your tables and creating relational structures is just something that you don't do in DocumentDB. So the great advantage if you're going to work with DocumentDB is really consistent writes and quick reads from the database. And it is a NoSQL database as a service, so you're not going to install it on-premise. You're going to actually go to the cloud and work from it there. So to sort of get going, if you have your Azure account, you could go to portal.azure.com, and you'll see your menu of options. What you would do to actually create a new DocumentDB in Azure is you'd hit the New Plus button, you'd select Data and Storage, and this is where you get your different choices. So you would select Azure DocumentDB. You'd see your ID, so you could call it 24 hours past demo, for example. You could select your tier, what resource group you're with, and then it will show you your subscription information. So that's important too, that if you are planning on playing around with it, that you have enough credits to work with DocumentDB. And then what will happen is you'll see, hey, it's taking a few minutes to actually provision and create the DocumentDB in the portal. So then once you get going, it's important you're going to have to know what the URI is of your DocumentDB. And then you're going to get your key so that you could actually programmatically work with DocumentDB. So what I'm going to do is just quickly switch to the Azure portal and show you pretty similar stuff that we had with the slides here. So if you're inside your Azure portal, you can see this pretty much matches what I had for the print screen when we got going. You can actually change your accounts. So if you have more than one subscription, you can go ahead and click on second RevGen subscription. And so it will reload the portal. And so what we would do is click on, after this loads, say new, data and storage, Azure DocumentDB. So it'll check that that's a valid name. Select a resource group. We'll use an existing one. Say what subscription, it's a premium one, and then location. I'm located in Colorado, so I'll go with West. And then we'll just click the Create button. So it's as easy as that. We're making another instance of Azure DB. So my understanding from the Azure website is you could create up to 5 of these database accounts. So you might have different reasons for your different applications and geographies and whatnot. I also saw that you could create 100 databases inside each account that you have. And right now you could provision up to 500,000 users to get access to the data. So I thought those were some interesting statistics. The number of attachment storage per database account is 2 gigabytes of space. And then there's a few maximums, like the maximum request units per second for a collection is 2,500. There's limits on how long some of the execution times take, like for example the max of 5 seconds. And then I think one of the most important questions was, hey, if I have a document, what's the maximum request size that I could have with that? And that's half a megabyte right now. The response size, so when you're writing a query and getting data back, is 1 megabyte. So those are some interesting statistics as this is rendering. So while it's sort of loading and running, again, reiterating, Azure DocumentDB supports the JSON documents. So a lot of programming like you're used to in transactional SQL is just not what you're going to be working with DocumentDB. So in playing around with the software development kit, there's a lot of programming that you would be doing in JavaScript if you got really deep into creating your UDFs and your stored procedures. So you might say, well, does that sound like a good thing? Well, from a .NET developer standpoint, it's probably a great thing. They're very used to syntax and figuring out logic. So it's a very good thing from that standpoint, from maybe a database administrator if you're trying to write SQL, not so much. So when you say JSON, what's the big deal? Why do we care? And so high level, it is a lightweight data interchange format. So if you're collecting data and you're going to push it into the cloud, you want to figure out a way to get the most data moved as fast as possible. Again, it's pretty easy for humans to read and write. Machines can parse and generate JSON, and it is a subset of a JavaScript programming language. There are some notations and conventions that are similar to the C family of languages. And so a lot of this has really taken on a great deal of interest from developers to just work inside of the JSON environment with transferring data. So what you need to really think about when you're digesting JSON is that it's an object and you have name value pairs with it. So when you're creating your data, you're going to start with a left bracket and a right bracket with a name and a value followed by a semicolon. So you could have, in this case, you have an object and you have a string with a name and then a value. You could create arrays of name value pairs, and so I'll have an example coming up with that kind of data. So you can have a string, double quotes number, true or false, or an object and array. These can be nested. So again, you could have objects inside of objects, arrays inside of arrays, with different levels inside of it. It can get, when we were actually implementing with the JSON, the simpler the structure, the better. You can do anything that you want, anytime, of course, but I would recommend minimizing the levels that you have and not create objects unless you really need to. And then you do have use of numbers inside of your JSON. The only thing you can't do is the octal and hexadecimal formats. Those aren't used and aren't complained. One question would be, well, hey, I like XML. What's the difference between XML and JSON? So we can see on the left side what an XML document would look like. You have your root. You're being explicit inside your tags with your employee name with the quotes. So it's sort of similar. When you get down to role, you have role and then bracket, then item, and then a role ID inside, versus you create a role with the array, role with the ID, role with the developer. So if you look at the total amount of characters created, XML versus JSON, you're going to see there's a lot less with that. And when I was doing a little bit of research as well, I'm like, well, is this just my example that I made up? Is it really going to transfer faster? What are some of the benefits of JSON over XML? So because there are less words in verbose, you can see that one of the benchmark tests, and you could go to thecodeproject.com and you could see some of the numbers and you could download example solution to work with this. But you're seeing 84% overhead with the XML versus JSON when you're working with 2 million rows of business data inside of an object. So when you're compressing data, it compresses a little bit more. It saves you space, and same with zipping. So you could say JSON use cases. Is there any real work situations come across where I actually wanted to use JSON or XML. So in my past projects, I've done a lot of work around data modeling where we've created scenario-based tools where we would process different ranges and payouts across different metrics. And so some of this gets complicated. So we've seen what we've called a payout rate card where we've had almost 1,300 combinations of two metrics to have payouts on. So one of the ways we saved this data was in JSON. So some further benefits as well is that you could avoid some of the serialization development that you would have of mapping in SQL to objects. You could, and we have, passed JSON from a UI to a stored procedure as just a JSON string, and it saved a ton of mapping effort with parameters. So in one case, if we weren't going to pass JSON or XML, we would have had 80 parameters in our stored procedure, and you'd have the middle layer mapping and effort and testing to make sure everything was okay. So I'll go through an example later that is easier to follow than a full set of 80 parameters, but it was very beneficial to have that. And so when we're saying how would we visualize this payout rate on metrics, you can see that this is a subset of the total 1,300, but you'd have 36 rows by 36 columns. You can actually save your data as an XML data type, and that's what we had done in our project where we got it from JSON. But you can figure out you're on X range, and you could go over to get a particular payout for sales commission data. And I know that with SQL Server 2016, they're going to support some native JSON types. However, in the short term until 2016 was released, there's another excellent website that talks about how you could take JSON from a web application and save it into SQL relational tables. So I have some code examples later that sort of walk through that, but I would suggest that we take the JSON, we save it in an intermediate table. There's a conversion to XML, and there's native XML functions inside of SQL Server. We then take the XML and save it into tables. So that's what that example code has from that website, are the extra functions and pieces that you could add to your SQL Server to load that in. I did have a conversation with somebody who had a very large JSON data set, and it becomes a constraint in memory. If you're talking gigabytes of JSON data, you might run into performance issues using this technique. If you have small to moderate size data, this seems to work fairly well from transferring data from your web app into your database and saving it as relational data in SQL Server tables. So another thing, once you start working with JSON is, well, I really want to work with, if I'm making a JSON document, an accurate one that's parsable, that doesn't have bad data information in it. So there is a JSON viewer in Notepad++ that you could download and use. And so you can make your JSON strings on the left side, click the viewer, and you're going to get an object. So at this point, before I jump into the demo, have we received any questions that we would want to talk about? Okay, take that as a no.
Available as a standalone product.
Okay. So if we're in Notepad++, so what we could do is take this JSON document, and so if you start working with DocumentDB, there's an SDK, and this is one of the standard JSON examples with that. You're going to see I have an ID, which is the Anderson family. I have a last name, which is Anderson. I have my parents, my name, my kids, etc. Children. So what if, is this really valid or not valid? So if we go to plugins, go to JSON viewer, could say show the JSON viewer. So it's taking the JSON as an object. So you see ID is Anderson family, last name is Anderson. We have parents, which is an array, which contains family name, Thomas, and my mother's name is Mary Kay. They would have children. So one child, Henrietta. An address, so Washington County King, Seattle, and is registered. So if we were working with JSON and we added something that made it invalid, and we say, all right, let's show what it looks like, you get a could not parse, and it actually takes you to the place where you have bad JSON data or incorrect syntax. So that's been extremely helpful in the development that we had done to make sure that we're getting accurate information. So that would be something else. So if you say, I'm going to change my JSON around a little bit, that looks horrible. I don't like the format of it. I could come in, go to my plugins, JSON viewer, reformat the JSON. So it's nicer looking. It's compliant to what Notepad++ is for style. Let me come back. So getting into a little bit more about DocumentDB now. So we're understanding we're going with JSON documents. We're going to be putting data in. But why? What are some of the cases here why we want to use this? So we're going to produce a lot of data from our applications. So in some of the projects I worked on in manufacturing, we had manufacturing tools that produced from solar panels of power curves and graphs and things like that. So large amounts of data. In some cases, it was so much data that it was very difficult to store quickly inside a SQL Server. So this gives you a possibility of loading it somewhere else and again in the JSON format really fast. What's nice about it with when we say schema free and not having to force a schema on something, you don't have to spend effort in modeling and design. There would be a little bit of thought into DocumentDB. Would I want to put it in a container, for example, with like JSON data? So when I'm running queries, things make sense. It's not a requirement, but I found it so far in the playing around to be sort of a logical thing to do. And when we talk about more, modern applications, you're going to see web applications that are working with AngularJS and could use Node.js. So that might be outside the scope of what we're really interested in from a back-end standpoint. But that's going to talk and work directly with the Azure DocumentDB. So there is an API and a SDK kit that you can play around with so that you could do some things directly with JavaScript. One of my coworkers was playing around with it and discovered that you have to be a little bit careful when you're working directly with JavaScript that you're on the same domain. So if you cross domain, you could get an issue and it wouldn't work the way you would expect. So there's also a lot around indexing technology. So you can have this highly concurrent lock free strategy. And when we go into the Azure site, you could set your different levels on your concurrency. Then again, there's because it's fully managed, you don't have to manage the space of the server and size. You can upgrade and extend what you would want. And then database is automatically backed up, so it's something that you don't have to worry about. So there's this idea of provisioning your capacity. So if you want to pay for more performance, you can change your settings and play around with that. So when you get into consistency options, it's going to maintain at least 3 copies of your data, storing it on a physically different server. So you get your replication. And so this is where you're going to set that as well in the interface so that So the default is session-based. And so strong consistency, so it will always see a complete and consistent data. So what that means is you're going to have trade-off where your reads and writes are slower than the other three options. And then the application must always see the most current data is a good choice for putting on strong concurrency. If you're working with bounded, this is a possibility a client might see old data, and you're not guaranteed that you're going to see the changes in the order that they were made. So you could see out of order data. And you can also specify a limit to how old the data can be within a certain second. In some cases, it doesn't matter if your data is up to date or not, and you'll get faster performance with the bounded, but again, you have the trade-offs that you might see older data. Session, again, that's what is on by default, and so you're going to get other clients might be seeing same data or older values or out-of-date updates. Application works on behalf of the user, such as the blogging the application. So again, that might be a lot of data coming in, and you'll keep the session on. So eventual highest performance, and so it's going to put things in the database as fast as possible. But again, it might be out-of-date information, or you'll get out-of-order updates. So when we're talking DocumentDB resources, you're going to have your account where we use to create databases. You're going to have collections inside your databases where you're going to store your JSON documents, and you could actually connect an attachment to the documents that you're working with. You're going to have assign users with permissions to get in there. You can create UDFs, structs, and triggers. So when I was approaching what I wanted to load in, I was sort of viewing a lot of collections of like JSON documents. So I'd set a collection up with like properties and load the JSON in there. So another visualization, you have your collection, several documents in it. You have your stored procedures, triggers, and UDFs, which you can see from the application. There are stored procedures, which are written in JavaScript. That will let you do a few things. I have a very simple one. So I'm going to go ahead and jump into Azure DocumentDB and walk through all of these different things we just discussed. So we can see that we provisioned our 24 hours of past demo. However, I'm going to go back to my pre-setup version. All right, so we'll go to the RevGen DocumentDB demo. Okay, so we're going to see a few things. We're going to see I've been working with Azure DocumentDB, so I'm going to see total requests. I'm going to have different events. I'm going to have activity. I'm going to see how much the estimated spend is. This is where when we talked about configuration, we have default concurrency set on. Not sure what went on there, but I'll try again. Okay. So we'll see settings across the top. So if I click on settings, this is where we get our consistency. So like I said, the session is what's defaulted. You could change it to the other three options. Come into your keys. So this is where when you're working programmatically, you need to know your URI and what your key is to connect to send documents into DocumentDB. So a few other properties. So when we set it up, we know it's online. It's a standard account. It's from the West US. We have different roles that we have that we would say these are the standard roles. Using as a user access administrator and owner. We have different users that are subscription admins that are related, so we'll sometimes share our accounts on things. So if we go into Document Explorer, what we're going to get is we could have our database, which is our sample database. I have two of them, commission goal setting, and then we have a sample collection that we have in here. So we're going to see no documents are actually existing in our sample collection. So what we'll click on is add a document. And so you could actually come in and we'll take our example of the Anderson family. Copy paste. Oops. We could do an upload. So click on the upload. So it succeeded. So we'll see a couple things. With our Wakefield family, we will get an ID. So this has to be unique. So documents that are inside your collections can't share the same ID or it won't load for you. This is our JSON that we had before. Now if I come into my Notepad++ and let's say I'm going to replace the Wakefield with the Anderson family. Come down. Oops, that didn't work. You can make edits with it. So you could say, for example, Anderson family. You can say changes. Now let's say we put in bad JSON and we do a save. It won't let you do it because of a syntax error. So that's where we could be helped out with our Notepad++ so that we have valid JSON. Okay, save. Okay, so you can modify it right directly through the GUI, or you could do it via the back end. So this is our one document that we manually added for the Anderson family. If we come in and we look, we could have a person collection. So that was another one. So we have the Prius guy. I don't know who that guy is, but people tend to make fun of him. And then you could have a totally different database. So some of the examples that we had done working with commission processing, we would save our data there. So we'd get an analysis collection, or we could get a scenario collection. So another example would be, I have a scenario ID that I have with create, date, properties, etc. We have settings, and that was something I had preloaded ahead of time. So if we're going to take a look at what we have on the back end side of things, I think from a BI perspective, it would be something that I would want to do using SSIS, for example. So what you have to do to come in and work with sending stuff to DocumentDB is I have two examples. This one gets files from Azure, and I have another one that will send files to Azure. So what I have is just a loop container, and what we're going to do is say I'm going to point at my D folder, my family JSON files. I'm going to look for all files with extension JSON on it, so a fully qualified path, and then we're going to take that file, save it as a JSON file that we're going to parse. So as of now, there isn't a connector method to get to Azure DocumentDB, so you have to work with a C# script task. And when you work with C#, see we'll be passing in the JSON file because it's in a loop. You click on the editor. There's a few things you're going to notice. You will have to add the Microsoft Azure Documents client, and then you will want to add Newtonsoft .json. You'll go to your namespaces, and you'll refer to Microsoft Azure Documents client and link, and then you'll have your Newtonsoft JSON references. Now, one thing, if you haven't worked with SSIS and script tasks where you've added DLL, the Microsoft Azure document had come with the SDK, and so you actually have to use the GAC util to register that, and then you have to put the DLL file as part of your SQL Server in your SQL Server file for your DLLs. Otherwise, if you don't do that, it'll compile, but when you run, you're going to get a reflection error. So you have to remember to register your with the GAC utility for those two DLLs. So what we're going to do inside our code is we're going to take and get a database ID, a collection ID. We're going to get the endpoint URL and the authorization key. So when we created our DocumentDB earlier, those were properties that we saw was the endpoint URL, the authorization ID, database ID, and collection ID. We could have passed these in if we wanted to, but I chose to actually create settings to do that. So if you right-click on your project and you go to Properties, you will also have to come in and set your target framework for 4.5 or 4.51. Otherwise, you won't be able to compile those DLLs either. If you come into Settings, this is where you're going to see database ID is the sample database that we had seen. The collection ID is the sample collection. The endpoint URL, that's a RevGen demo. And then we have our authorization key that was created for us when we created our DocumentDB account. So those are important. We get those. Then we start our main script. So this is where we have our JSON file string, and we're getting the JSON file from the loop. I set a little debug flag to pop up error messages to see if we're actually connecting and pulling the right databases and collections and endpoint URL and JSON file in. Then we have this run demo async. So this was code that I leveraged from the SDK, and so we're basically passing to this method the JSON file, the database ID, and the collection ID. The rest of the stuff is error handling, so if something goes wrong where we're not able to connect, this will throw an error. And then if we're in debug mode, we'll say end of demo. We could hit the enter to continue. When we're running the async demo, which was called from the main thread, again, we're passing in the JSON file ID, the database, and the collection. So we're getting or creating it. So what this code will do is if you didn't create the database ahead of time, it'll create it programmatically in code. And if the collection doesn't exist, it will create it for you. So that gives you the flexibility as you're working with data. If you need to put it somewhere different for some reason, you can do it programmatically, so you don't have to go into the UI to do it. Now what this is doing using streams, so this is going to actually take the file, this is a little bit of C#, you're getting the file, and you're doing a file stream to read it into the document, and you're saying, hey, I'm creating the document in DocumentDB using the file stream. And then these are just the methods to get or create the collection that you have in DocumentDB, and this is the method to get or create the database inside. And that's the code. So first glance, if you haven't done a lot of C# script tasking inside of SSIS, it's good to get familiar with a couple of the concepts. And then what we'll do is we'll say OK. And we'll keep it in, I can put the debug mode to true, so we'll get our pop-ups. We'll go ahead and do one more check. I want to make sure that this is the folder, and we're going to load 6 documents into the collection. So go ahead and we'll start run. So we're putting it into the sample database, the sample collection. We're using the demo, and this is going to load the Hawkeye family. So it successfully did it. Now we're in our loop. It's running the Barra family. Okay, we're good. Green. Yay, success. So I want to know, did that actually do anything? So if we come into our Document Explorer, and so let's do a refresh. We'll come into Sample Database, Sample Collection. Yay, success. We loaded 6 new files in. So for example, we look at Hawkeye family, see Hawkeye, we could come to Abara, see Abara, we could come to myself, see my profile with my docs. So we successfully loaded through SSIS data into DocumentDB. So now we want to say, hey, what would we do to actually get some of this data out? So we have a set of queries that we could do. So if we come into Query Explorer, we can say, okay, the default select start from C. Normally select star isn't the best thing we could do. We'll go ahead and run it anyway. So what we're going to get, and this is where first looking DocumentDB, you're like, what's going on? You have an array of JSON documents. So it started with angle bracket. This is the Anderson family. It ends, and then you're in the Hawkeye family, and then you're in the Barra family. So there's not really much going on. So we don't want everybody. We can actually apply a where condition. So we would say just select all columns from families where the family ID is the Anderson family. So if we look at the JSON that we have, we're calling the ID object, and we're filtering it on the Anderson family. So now when we run this, we get only the Anderson family. If we were going to, let's say, filter on a city, oops, could write run query. There's nobody from Seattle. I think there's somebody from Denver, maybe. Yeah, there we go. So Hawkeye family was from Denver. So the other thing, this is where we're sort of getting SQL-like syntax, which is what they promised, but this is the only SQL type thing I noticed. You can see we got the Anderson family. They're from New York, or the Wakefield family. Say the Renz family. And so I'm from Thornton, etc. So what I'm sort of getting at as well is when we had the families, you could explicitly say a last name recasted as name. You could go down to where the city was, which was lower inside the JSON part of the properties inside. You can get at that as well. You can do joins as well inside the JSON documents. So we can say, let's go ahead and get just the family and the children and the pet. So we're recasting the given name as the pet. So we'll see Anderson family has Jesse, who has Goofy as the pet. We have Jesse and Shadow. Our family has Poofus. Mugwai, I have 2 dogs. So sort of cool syntax there. Now let's say we wanted to get all the pets that we have. Come in and we could run and get the pets. So these are all the pets that exist from all our JSON documents. So that's how you query and get data out. So what I had talked about as well is what do we want to do if we want to actually get some of the stuff inside of SQL Server? We want to do more with it. So we have all these documents. What can we do? So there, if you look at this JSON database that I made, and I won't go through all these scripts due to time, and you go to the blog site that I mentioned earlier on how to convert JSON into SQL, you will see that we have a set of functions and views where we're parsing JSON and XML to load this in. And what we're trying to do is have a stored procedure that we call where we don't have, in the case of like 80 parameters, we have 1 parameter. We're getting JSON, which is a varchar max. So steps again, when we had done that, we're saving to a hierarchy temp table, we're converting to XML, we're then getting the records, and we're querying from our XML nodes to figure out how we're going to load data in. So we're going to have scenario values that we create and load them in that way. So when we go to our databases, and we say commission goal setting, and we have scenarios, and we say select. Let's see. It's running. We're going to get scenario 1, which was created, and that's all that was preloaded in. So again, more stuff you could do programmatically. I actually have a tool, so we could do JSON comparisons. But if we come into applications and we have create scenario, I'm going to call this scenario ID 2. We're going to save scenario to the DB, which is going to actually save it to DocumentDB. We're going to come in and we're going to say number 3, save to DocumentDB. So we have 3 scenarios. Let's go to DocumentDB and see if we actually loaded any more scenarios. 1, let's come back. Just hold on. Document Explorer. So we loaded 2 more, so we have 3 total scenarios that we created through our Windows tool. And so what we're going to do is say this is a scenario table we'd want to have in SQL. It's a one-to-many join to the setting table in SQL. So if we look at it here, this is our scenario table where we have our scenario properties, and then we have the setting table, which has setting ID and description, but basically setting value inside of here. So to run that, we will come to our other SSIS package to get that in. So this is going to be send, so we're going to get our Azure DocumentDB documents. So this is a script task. So again, because there's not a connector, we're going to have to do C# script tasks. And this is where the Newtonsoft JSON is important. So we're writing our SQL query, select all of these. You could do it in the UI to figure out your syntax. We're going to say how many JSON documents did we get back. We're going to connect to my local SQL server, which is JSON. We're going to create a call to stored procedure save scenario. We're going to pass the JSON in as a parameter. We're going to then, for every document that we have, loop through it and actually call it to insert it into SQL. And that's pretty much what we're doing. So this will take one more check here. So what we want to see is make sure that there isn't any data in the scenario tables, which there isn't. Go ahead and run our SSIS package. So we have 3 results back of scenarios. First one is 1, 2, and 3, and it's done. And then we look inside SQL Server, and now we got our data out of DocumentDB and saved it relationally. So I believe, Martin, we only have a few more minutes left. I'm wondering if we should, if I could spend 1 minute talking about JSON validation, and then we could go into questions.
Yep, sounds good to me, Jeff. I've got 2 questions here waiting for you.
Okay, so what you will want to do, there's a website for JSON schema validation that you want to go to. So there's a bunch of different things you could do. You could allow additional properties. You could force required fields in JSON, and you could restrict values to an enumeration. So again, if we had our settings, we might want to put something into the effect that we want to force certain fields to be there if they were required in our database, which we could do with our schema binding. So what I'll do is bring up a parser example. And so if we're looking at this, we're going to have 2 things. We're going to have JSON on the left side, and then we're going to have schema on the right. So we're going to actually see, I am going to have name, hobbies, car model, city. Those are what JSON you could provide. You don't have to provide it, but you're not allowed to provide something extra. So we're going to take the JSON, we'll do the Newtonsoft to compare against the schema, and then we'll say, are we good? So we got the check mark that says we're good. Say I get rid of the city, and I hit validate. We're still good. It's not required. It's optional. But if I come in and I say state, I put in a CO, and I validate, that's invalid because you can't add additional properties. That's what that means. The most interesting one is enumerations. So let's put in enumerations, and I'll validate. Let's see, we're trying to validate here. Okay, well, we're short on time. I need to jump to questions, I believe.
Okay, Jeff, no, that's cool. That's cool. I'll just read the first one out. What are some use cases where DocumentDB is advantageous over Azure table storage? Are storage and bandwidth costs comparable?
So I'll have to get back on the cost differences, but the idea would be there's extra capabilities inside of DocumentDB to allow you to like index and get better performance searching through your data, especially your JSON records, to get data back out. So I didn't get into how you would actually put indexes on your collections, but you could.
Okay, that's cool, Jeff. I'll just go to the second one. So searches in schema-free DocumentDB would be faster than in a usual schema database, and for searching for date time or in data type. Can you talk about that?
So I wouldn't necessarily, again, when you're working on your databases, it depends on your indexing strategies that you have and the amount of data that you're looking for. The advantage of the DocumentDB is the quick saving of your data, and then you can apply indexes to get it out. I wouldn't necessarily say it was a general rule of thumb. One would be faster than another, although I would probably lean towards relational databases. If you're doing modeling and design, you're going to model your tables in a way for performance. And again, if you had your data warehouse, for example, and you're applying like columns or indexes, that could be a totally different performance than your indexing with the DocumentDB.
Yep. So I guess a typical database person's answer, it depends there, Jeff.
I'm sorry. I wish I could be a little more specific, but
Yeah.
I would say your strategy for your database itself in SQL is that you're planning your design and your structures, and especially if you're having a data mart style database, and you organize your data in a very structured way, and you're taking advantage of column store indexes, that seems like your performance will be better than just storing stuff in DocumentDB.
Okay, that's great, Jeff. Just like to thank you for putting together that presentation. I think DocDB is going to be very, very interesting over the next few years and maybe get a lot more adoption. So thanks for putting together that pretty informative presentation. I guess all that remains for me to do now is thank the audience for joining us. And I'd also like to thank our presenting sponsors, Microsoft, Cisco, and Dell Software. And in addition, I'd like to thank our supporting sponsors for this event, SQL Sentry, Hewlett-Packard, and SolarWinds. We hope you've enjoyed the session as much as we did. Follow along on social media with the @past24hour Twitter handle or #past24HOP. Hopefully you'll stick around for the rest of the 24 hours or dip in and out as you see fit. So thanks again, Jeff, and thanks to the audience.
Thank you.